What if the universe you see around you is not real? What if the stars glowing above your head, the galaxies stretching across unimaginable distances, even the ground beneath your feet, are nothing more than an elaborate illusion? Humanity has always trusted its senses. We believe in what we can see, touch, and measure. But history shows us that our senses can betray us. A straight stick looks bent when placed in water. A flat image can appear three-dimensional. A shadow can trick the mind into seeing movement where none exists. These simple illusions remind us of a sobering truth. The mind can be deceived. Now imagine that same deception on the grandest possible scale. What if the entire cosmos itself, the fabric of space, the flow of time, the matter and energy we think are solid, are nothing but projections, shadows of something deeper and unseen? This is no longer just the territory of philosophers or mystics. Today, many of the world's leading scientists are daring to ask these same questions. Could the three dimensions of space be nothing more than the surface of a hidden two-dimensional reality? Could time itself be an emergent illusion? For centuries, physics promised certainty, a universe ruled by order and predictable laws. But as researchers probe deeper, into black holes, into the quantum world, into the very code of reality itself, they find something profoundly unsettling. At the smallest scales, reality begins to blur, twist, and defy common sense. One physicist put it simply: the closer we look at reality, the stranger it becomes. This documentary is a journey into that strangeness. From ancient philosophy to cutting-edge physics, from thought-provoking experiments to mind-bending theories, we will confront a daring possibility: that the universe, as real as it feels, may not be real at all. Since the dawn of human thought, people have asked one of the most unsettling questions imaginable. What is reality? Ancient cultures built myths and cosmologies to explain the heavens above and the ground beneath their feet. Yet even in those early times, some suspected that the world was not as it seemed. To the naked eye, the earth feels flat and still. Yet careful observation revealed motion in the stars and a horizon that bends with distance. Reality even then was slippery, demanding closer inspection. In the age of classical philosophy, thinkers like Plato gave this suspicion a powerful voice. In his famous allegory of the cave, he imagined people chained in darkness, able to see only shadows cast upon a wall. For them, those shadows were reality. But Plato argued that a higher truth existed beyond appearances, a realm of perfect forms unseen by the senses. Centuries later, René Descartes echoed this doubt in a more personal way. He asked, how can we ever be sure our perceptions are real? Perhaps an evil force or even our own minds are deceiving us. His conclusion was radical. The only certainty was thought itself. I think, therefore I am. As the centuries turned, science reshaped the question. Isaac Newton's vision of the cosmos was a universe of precision. Solid matter moving through absolute space and time, governed by laws as steady as clockwork. To many, this seemed like the final word on reality, clear, measurable, and unshakable. But the 20th century brought an upheaval. Albert Einstein revealed that time could bend, stretch, and warp with gravity, and that space itself was dynamic. The supposedly solid framework of reality was already cracking. Then came quantum mechanics. At the smallest scales, particles refused to behave like solid objects. They flickered between possibilities, uncertain until measured, as if reality itself needed an observer to bring it into focus. Werner Heisenberg described it bluntly. What we observe is not nature itself, but nature exposed to our method of questioning. Suddenly, the dream of a stable, unquestionable reality collapsed into a haze of probabilities and paradoxes. Today, scientists revisit these ancient suspicions with powerful new tools. Black holes hint at hidden dimensions, quantum experiments suggest reality is far less solid than we imagine, and cutting-edge theories whisper that what we call the universe might be a projection of deeper, unseen laws. In this way, the questions of Plato and Descartes are not dead. They have returned with greater force than ever before. The possibility that reality is an illusion has shifted from philosophy's shadows into the bright spotlight of modern science. At the heart of modern physics lies a possibility so strange it sounds like science fiction. the idea that the universe may not be what it appears to be. Far from being a stable three-dimensional reality, it could be a projection, a code, or even a kind of grand simulation. To grasp this possibility, we must travel through some of the boldest ideas science has ever produced. One of the most fascinating is the holographic principle. Imagine a hologram, a two-dimensional surface etched with patterns of light that, when illuminated, create the illusion of a three-dimensional image. What if our universe works the same way? According to this principle, everything we see in three dimensions, galaxies, stars, even ourselves, may be encoded on a distant two-dimensional boundary, like a cosmic film screen projecting the illusion of depth. This radical idea was born not out of imagination, but from the mathematics of black holes. Black holes, those mysterious regions where gravity crushes everything, provided a clue that led scientists to rethink reality. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered something shocking: the information describing everything inside a black hole. The matter, the energy, did not disappear as expected. Instead, it seemed to be stored on the black hole's surface, a two-dimensional horizon. This observation hinted at a deeper truth. Perhaps the entire universe itself behaves like a black hole, with its information encoded on a boundary we cannot see. But the mysteries don't stop there. In the realm of the quantum world, reality grows even stranger. Subatomic particles refuse to sit still. They exist in states of uncertainty, existing as probabilities until observed. The simple act of measurement seems to force reality to choose. Physicist Niels Bohr once remarked, "Anyone who is not shocked by quantum theory has not understood it." Here, the role of the observer is not passive but active, as if consciousness itself is woven into the rules of existence. Is reality waiting for us to look before it solidifies? And then comes the simulation hypothesis, a concept popularized by philosopher Nick Bostrom. If technology continues to advance, future civilizations may be able to simulate entire universes on powerful computers. If that is possible, Bostrom argues, it might already have happened. We could be living inside such a simulation without knowing it. To illustrate, think of modern video games. A digital landscape can mimic forests, oceans, even weather systems, yet they are nothing more than strings of code. Could our own universe, with its mathematical elegance and strange quantum rules, be running on some cosmic processor? Scientists debate fiercely between models like these: holography, simulation, or the idea of emergent space-time, where time and space are not fundamental but arise from deeper hidden laws. Each framework attempts to explain why the universe behaves the way it does, but none yet offers the final word. For the public, metaphors bring these ideas to life. Imagine looking at a hologram, a flat image giving the illusion of depth, or putting on a virtual reality headset and being transported to a world so convincing that your senses cannot tell the difference, or zooming in on a digital screen until the individual pixels become visible. Could reality itself be pixelated, made up of the tiniest building blocks of information rather than continuous space? The pioneers of these theories, Gerard at Hooft, Juan Maldacena, Nick Bostrom, among others, acknowledge both the beauty and the uncertainty of their ideas. Maldacena's work on the holographic principle sparked a revolution in theoretical physics, while Bostrom's thought experiment forced both philosophers and scientists to take the simulation idea seriously. And yet, for all its brilliance, much of this remains unproven. Some experiments, like those testing the limits of quantum entanglement or the behavior of black hole radiation, may provide clues. Others, like searching for pixelation in the cosmic background of the universe, attempt to reveal whether reality has an underlying digital structure. But as of now, these remain tantalizing theories, not settled facts. What science can prove is this: reality is stranger, more fragile, and more layered than common sense would suggest. Whether hologram, simulation, or something beyond imagination, the universe is not a simple, solid thing. It is a puzzle whose pieces we are only beginning to glimpse. The idea that reality might not be what it seems does more than intrigue philosophers or excite scientists. It challenges the very boundaries of existence. If the universe is a projection, a simulation, or an emergent construct, then our understanding of who we are and where we stand in the cosmos must be rewritten. For centuries, people believed the universe to be solid, reliable, and grounded in laws of physics that would never bend. But as science reveals deeper mysteries, the foundation beneath our certainty begins to tremble. It is not only a question of physics, it is a challenge to the human sense of meaning. The ripples extend beyond imagination into the world of practical science and technology. The same mathematics that suggests a holographic universe also drives advancements in quantum computing, cryptography, and information theory. If reality itself is built on information, then understanding those codes could transform technology in ways we cannot yet predict. Imagine computers that harness the rules of quantum strangeness to solve problems beyond any machine today. Imagine physics leading us toward new energy systems or breakthroughs in space travel by uncovering hidden layers of reality. A scientist at MIT once remarked, "If the universe is code, then learning to read it may be the most important scientific project in history." But there is a more intimate layer to this debate: the ethical and philosophical consequences. If reality is in some sense an illusion, then what does that mean for free will? Are our choices our own, or are they predetermined within some cosmic program? For some, this realization inspires humility. Our lives may be threads in a larger tapestry beyond our comprehension. For others, it sparks discomfort, raising the possibility that purpose itself is constructed, not inherent. And yet, even if reality is illusory, the emotions we feel, the relationships we build, and the experiences we live through remain undeniably powerful. Illusion does not mean insignificance. Culture has long anticipated these questions. From Plato's cave to the Matrix, from science fiction novels to Hollywood blockbusters, art has explored the haunting idea that reality may be fake. These stories shape the way audiences think about science, often making complex theories emotionally accessible. When a viewer watches Neo swallow the red pill, or when audiences imagine life inside a digital world, they are engaging with metaphors that mirror the debates of modern physics. Science and culture feed one another. Theories inspire stories, and stories push people to ask deeper questions. This leads to perhaps the most pressing question: if reality is not what it seems, how should we live? For many, the answer is surprisingly grounded. Whether real or illusory, the moments we experience are ours. The laughter of a friend, the beauty of a sunrise, the pursuit of knowledge, all remain profoundly meaningful. Some philosophers argue that acknowledging the universe as an illusion only deepens its mystery and makes life more precious, not less. Scientists, however, remain divided. Some, like proponents of the holographic principle, are convinced we are on the brink of a new understanding of reality itself. Others caution that these are beautiful but untested ideas, pointing out that without solid evidence they remain speculation. It's important to remember, one astrophysicist notes, that science thrives on uncertainty. A theory is not truth, it is a stepping stone toward it. And so the debate continues. Between believers and skeptics, philosophers and physicists, artists and technologists, the idea that reality might be an illusion refuses to fade. Instead, it pushes us into uncharted territory, where the boundaries of existence are no longer fixed lines but shifting shadows, inviting us to look closer. Reality, as we have explored, is not the solid ground we once believed it to be. From the shadows of Plato's cave to the shimmering equations of modern physics, every step forward has revealed layers of uncertainty. What we've learned is both humbling and awe-inspiring. The universe may not be a stage built from stone and steel, but from fragile threads of information, probability, and perception. Yet, with each revelation, new mysteries arise. Scientists still wrestle with the same haunting questions. Is the holographic principle truly the blueprint of reality? Does quantum mechanics hint at hidden realms we cannot yet see? Could we, as philosopher Nick Bostrom suggested, be living inside a grand simulation? None of these questions have definitive answers, but they remind us that science is less about final truths and more about continuous exploration. The future of this exploration lies in extraordinary tools. Quantum computers are beginning to probe the limits of information itself, cracking puzzles once thought impossible. Next-generation space telescopes are preparing to peer into black holes and the very edge of time. Particle accelerators, too, may one day reveal whether space-time is emergent or if the simulation hypothesis carries weight. And yet, beyond the experiments lies a deeper reflection. Whether reality is solid or simulated, projected or emergent, it is the only canvas we have for meaning, love, and discovery. As one physicist remarked, even if we are in a simulation, the sunsets are still beautiful. Perhaps that is the final lesson. The mystery of existence is not diminished by uncertainty, it is amplified. Illusion or not, the universe remains our greatest story, and we are still learning how to read it.